Welcome to Lesson 12E, Exhaust Duct Introduction. We're going to spend a few lectures now on exhaust duct design, so here's a quick introduction. This is mostly review from our undergraduate fluids class, but we'll need some additional considerations for HVAC type applications. Let's do a typical type of schematic of some duct with a fan. Now we'll always have a shaft here that we don't usually show, but that will be W.S, the shaft power to the fan. And then we have a hood drawing in air. We have a damper, also called a blast gate, or it's really just a valve, basically to control the flow. This is all review of your undergraduate fluids class. So we'll talk about major losses, frictional losses, and these are dealing with long, straight sections of duct. And then there's so-called minor losses, which is anything else, so all other losses. That would be your valves or dampers, elbows, etc. We use the energy equation from an inlet to an outlet, just like we did in fluids. But in fluids class, we're typically talking about water flow in pipes. Now we're talking about airflow in exhaust ducts. There are some additional considerations when we're talking about exhaust ducts. The first thing you may have noticed, there's something here called a dropout box. What that is designed to do is to remove particles from the duct flow. So you can have vapors through the duct or you can have particles. If you have particles, we sometimes want to remove those particles. So the one I sketched is a kind of a tank that hangs down in the duct. By the way, I'm a fluids guy primarily, so I'll sometimes say pipe instead of duct, but we're talking about ducts here.
Hey, Duck, the professor's talking about you. No, he ain't, Dick. It's duct, D-U-C-T, not duck, D-U-C-K. Oh, right.
You have the air going through, and it has particles in it. And the particles are heavier than the air, so they tend to drop down, and then they start collecting down here to the bottom of that drop box. You have to clean it out every once in a while. There's some other kinds that look similar but have a baffle in it. What happens there is the air has no trouble going around that baffle like that, so you have these streamlines of air that come through like that. There's going to be some turbulent separation and mixing and stuff, but in general, that's what the airflow is doing. Now, it turns out that the particles start dropping like they did in the one to the left. But in addition, as the air goes around this turn, the particles cannot negotiate that turn. So they're going to be flicked off of the streamlines of the air. This is called inertial separation. And that's a very important way to remove particles. The basic idea is that particles cannot negotiate a sharp turn. So they are thrown radially outward. If you have any kind of a airflow that's in some kind of a circular flow, the particles, if here's a particle, they'll typically be flung outward, and that's called inertial separation. We'll see that over and over again later on in the course. Particles can also settle in horizontal ducts. If we have a long straight section of duct, and of course you have some U or V, the average speed in the duct. And suppose this is particle laden as well. These particles are falling and we'll be able to calculate how fast they fall. Some of them fall to the bottom of the duct, and so you get a dust buildup on the bottom wall of the duct. They can be dust particles or bigger particles. Why is that a problem? Well, it can clog the duct, which would not be very good. It can increase the pressure drop, delta P, and or if you think about your fluid mechanics, if you have a higher pressure drop and you have a given fan running, it'll slow down the flow so it won't be going as fast, which actually makes this problem worse because the smaller U is, the faster this dust builds up on the bottom. So it's a kind of a self-defeating thing. It can cause fires if you have certain kinds of particles in there that you don't want. And all this dust buildup, it can get heavy and can lead to the duct collapse. This is a structural thing that we never really thought about with pipe flows. If you have water in a pipe, you don't think about pipe getting heavier with time, but these things keep getting heavier. This dust buildup has some weight to it. Some examples of collapsed air ducts due to too much weight. Here's from the UK. There's a collapse on students that happened to be taking an exam at the time, and this duct collapsed on them. Here's a case where 8 children and 6 adults were injured at Shaler. That's near where I grew up. A duct collapsed here. A similar kind of picture. The whole thing came down. Here's a car dealership. This duct fell right on a BMW. Bummer. Here's a picture looking into a duct that has lots of accumulated dust. And so you can see how that dust is just on the bottom there, and that can get heavy if you never clean it. There are companies that clean ducts, and you'll see this kind of an advertisement here where this company says this is before and this is after cleaning. It's a vendor, so they're showing that their process can remove some of that dust. This is a round duct. This is what you might see in a laundry dryer hose. And if you've never cleaned the dryer hose coming from your dryer, there's a duct that goes outside, and there's all this lint that builds up, and it can start a fire. And so you really should clean that out every so often. What I do about once every year or so is I separate that duct from the back of the dryer, get my leaf blower, put a towel around it to make kind of a seal, and blow it out, making real high speed through there. And my wife stands outside and can see all this lint coming out. We do that for a few minutes until the lint stops coming. And that way I just blow all that out. Again, if you don't do it, your dryer is going to have a harder time pushing the air through. Therefore, it slows down. It gets much hotter than it should. It makes the dryer less efficient, and there's all kind of problems that come with that. There's some other issues when you have vapors. They're often hot and the ducts are cool, and that's a recipe for condensation. So whether it's water or some other chemical, especially if it's some kind of acid, you get condensation building up. So if this is the cross section, you'll get droplets occurring, and this can lead to corrosion and some other problems. You can also have explosions or fires in ducts, so be aware of the LEL, lower explosion limit, which we talked about before. And some serious fires have started in ducts. A final comment here, we generally don't care about PEL, the permissible exposure level, because people aren't inside the duct. So we don't really care if the PEL is exceeded, but you really have to be careful of the LEL. You can't have too high concentrations going through these ducts because there's often sparks due to static electricity, and you can get explosions in ducts. Next time we'll start on the equations that we need to solve flow through ducts.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos. 1, 2, 3.